Hi, today's lesson is going to be on sequences, and the learning objective is to be able to predict the next term in a sequence and to be able to describe the rules for sequences. So sequences is just a list of numbers that follow a pattern. And so first thing I'd like you to do is copy out the sequences and write the next term and a description of the sequence in each case. So copy out these four here, and just what's coming next, and what's happening. Just write it in a couple of words. And then if you are feeling confident, you can have a go at numbers 2 and 3 yourself. I think that if you struggle with number 1, you might just want to listen to explanations for 2 and 3 afterwards. But this is something which is fairly logical, and you might be able to just have a go at it yourself. So as a starter, pause this now, have a go, and when you've had a go, unpause it, and we will go through what the answers are and how you should answer these sorts of questions. Okay, so hopefully you had a go at doing this, and let's talk about some answers. So first sequence, 3, 7, 11, 15. Hopefully you spot that the next number is 19. It's going up in 4s. Okay, so you can just say that the rule is add 4, because that's what's happening. To get to your next term, that's what you do. Add 4, add 4, add 4. To get to your next one, just keep adding 4. Then the next one. So we're sticking an extra 0 on the end. So you can easily figure out that the next number will be 50,000. But we don't want to put over here, put an extra 0 at the end. What's the actual mathematical operation that's happening? It's times by 10. So the rule is times by 10. Next one, times by 10, 500,000, 5 million, etc., etc. Okay. Then the next term, again, it's fairly straightforward to see that the next number is going to be 30. It's just going down in tens. So you could say in words going down by 10, but we can just say subtract 10, and that's going to be the easier way of saying it. And then this last one here, so it's halving each time. So half of 25 is going to be 12.5. And another way of saying half it is divide by 2. So you can see that the next terms you can figure out with common sense, and the descriptions try to put in a sort of mathematical operation rather than a long word description. It's easier and quicker to write, and it's more precise and a bit easier to use later on as well. So rather than put an extra 0 at the end, we want times 10. Okay, or any other things you can come up with which are long wordy explanations. These are going to be a little bit easier. And how to figure out what's next, if it's not obvious, these are the things you should be thinking of. Do you have to add something? Do you have to times by something? Do you have to take away by something? Just see what's changing between this one and this one. I might have originally thought that this was take away 100, but when I look at the next one, it's wrong. So, okay, let's go back. What else could I do apart from take away 100? I could be divided by 2, and that one works. So that's always what you should be thinking of. Right, then the next ones, which were a little bit more tricky, you might or might not have had a go at these, but we'll talk through them now, was the 8th term in the following sequence. So there's no real trick to this other than, well, we've been given 5. Let's just work out 6, 7, and 8. If it said the 800th, then we might have to do something a little bit more fancy. Okay, because we don't want to figure out all 800 terms. But because it's only asking for the 8th, we can just work through the next couple to get there. So what's happening? Plus 3, plus 3, plus 3, plus 3. Plus another 3 will be 20. Plus another 3 will be 23. And the last one's going to be 26. So the answer is 26, what we're looking for. Then question 3. Will 2155 be in the following sequence? Give a reason. Okay, so let's think about it. What's happening here? These are going to be 7, and then it's doubling and doubling and doubling. So what we could do is we could keep doubling until we get up to here, and then we'll see whether it's in there or not. And the other way of working it out, though, is, well, what do all these numbers have in common? These are all in the 7 times tables. Okay, so is this in the 7 times tables? We could check that. And yet another thing we could do is, because we're doubling, apart from the first number, when you double something, it's always going to be even. Will we ever get back to an odd number? No. So, apart from the first one, all the numbers in sequence are even. That's one way of doing it. Another way of doing it would be if I just keep doubling. Well, 56 times 2 is 112, 224, 448, 896, 1792, and then it jumps up to 3584. You could explain, because of the way the sequence goes, that it will not be in there, but that's obviously a lot more work, especially if you didn't have a calculator. And the other way I said was check, does 7 go into it? So if we take 2155 divided by 7, it doesn't go into it. So the fact that all those numbers have to be in the 7 times table prevents it from being in there as well. So there's 3 different reasons. When it's give a reason, there's not always one answer. Use logic and common sense. That'll probably be the trickiest sort of question you'll be asked. But apart from that, sequences is something that's fairly straightforward. Let's talk about a bit of terminology. Okay, so sequences, that's the list of numbers. Right, when it says next term, it wants what's the next number in the sequence. And when it's saying a description of the sequence, it wants what's the rule to get me up to the next number. Okay, so term, that's the number in sequence. The 8th term is what's the 8th number in the sequence. Description, what do you have to do to get to the next term. Some other ones. So sequences where the numbers increase, so if it was going 2, 4, 6, 8, they are ascending sequences. Ascending, think about ascending some stairs, going up, the numbers are going up. So if a question is talking about ascending sequences, you've got to understand that that means the numbers are increasing. And on the other side of things, sequences where the numbers decrease are descending, so like going down. The numbers are going down. Think about the word descending means going down, so it's going 10, 5, 2.5, 1.25. If they're halving every time, everything's going down. Okay. Now, in general, sequences are infinite. If it doesn't say anything to the contrary, then it means that it'll go on forever. It'll go 10, 20, 30, 40, 50, and carry on forever. And that will be what's called an infinite sequence, because there's no end. Now, if, though, they said the extra words that there's only 10 terms in the sequence, or the sequence stops when you get to 0, or anything like that, then it's what's called a finite sequence. So, a bit of extra terminology here to get your head around. Some of those words might come up in the questions in the exercise. The exercise I want you to do is exercise 9.1. Okay, answer it in the normal way, show some workings where appropriate, ask for help if you don't understand something, don't just leave it blank or put question marks, ask for help, either in the chat or email. Okay, look at the side of the page for tips and hints, look back over this lesson if you need to. There's lots of ways you can get help for this. Okay, so there's your exercise, and that's what you need to do.